Okay, hi Josh. I wasn't really sure what to do here, so I think I'm going to just go through a couple of the questions that I suggested were pretty similar to ones on the test. If you give me a little bit more feedback as to what specifically you're struggling with, I can give you something a bit more specific, perhaps. For now, I think this will get you going. So this is question 8. I said on the news post that it's pretty similar to one of the questions, at least one of the questions. So a little bit of background, if sort of in case you missed it. Um, there are two triangles that we consider special triangles. One is the isosceles here, and 45, 45, and a 90-degree angle on the end. And one is the 30, 60, 90 triangle. This is actually half of, if we had extended this out, wow, that's poor. This would be half of a equilateral triangle. Kind of why it's important, or kind of why we consider it special, but not particularly important to us. Um, Knowing that, and hopefully we can realize that we aren't working in degrees too often anymore. We work in radians. 45 degrees is the same as pi over 4 radians, because pi is the same as 180 in degrees. So basically, if you divide 180 by 4, you get the number 45, and that's sort of the equivalent of pi, again, being the 180 over 4. Same sort of idea here. 180 divided by 6 tells us that pi over 3 and pi over 6 are the same as the other two angles here. Okay, so that's kind of the basis of, those are the values we need to know to be able to do the substitutions so that we can then solve this. Go blue. Okay, cotan we know is 1 over tan. And so essentially what we're going to do is rewrite the information that we're given in the question so that it now looks, or sorry, it only includes ratios that we know, tan, sine, and cos essentially. That's a 4, maybe not super clear. See if I can do a better job. I apologize, I am writing on a tablet and not on the smart board, so it's a little tougher. So cotan, we can substitute to be 1 over tan. Cosine of pi over 3, I'm going to leave alone. I know how to work with cosine, so I can do a substitution here in a moment. Cosecant is the same as 1 over. So essentially this is 1 over sine of pi over 2. Okay, so it's a little messy, but essentially I've got information here. 1 over tan, so what I'm interested in now is what is tan, and if I know what tan is, of course I can figure out what 1 over tan is. Tan of pi over 4 is this right here. And when we have a right angle triangle with 45-degree angles, these two sides are the same length. So I can call them both 1. I could call them both 21 if I wanted to, but 1 just kind of makes it a bit easier. And root 2 is the third side. Basically square this side, add them together, and take the square root to find the missing side. So Pythagorean theorem gets us that value. Same sort of thing here, actually. What I know is that sine of 30 is 1 over 2, or 1/2. So opposite is 1, hypotenuse is 2. And then if I do some math, 2 squared minus 1 squared square rooted is root 3. Okay, so sorry, those are the pieces of information that needed to be there. And this is the thing that I suggested you need to know. I'm going to give you all the formulas as far as identities and so on go, but you do need to know these. They're not on the test. They're not given to you on the test. Excuse me. Okay, so 1 over tan of pi over 4. Um, tan of pi over 4, again, tan of 45 is opposite over adjacent, which is just the number 1. So what I'm going to do is rewrite this. I'm just going to leave sort of blanks for now, wherever I'm plugging in values. And so tan of pi over 4 is the number 1. Cos of pi over 3, if I come down here, here's my pi over 3. Cos of that is adjacent over hypotenuse, or 1 over 2. And sine of pi over 2 is not one of these. It's not a special triangle angle, but it's the same as sine of 90. And sine of 90, if you think about the fact that sine is saying, well, let's not worry about that, sorry. If you punch sine of 90 into a calculator, you'll find that that answer is 1. Okay, so it's not one of the ones that we've learned, but those key points, 0, 90, 180, and 270, 360, those will always be zeros, negative ones, these sorts of things. So those will be values that we can actually calculate. We didn't memorize them, but you can punch that into a calculator. You'll see it's just the number 1. And so now basically I've got some numbers here, 1 divided by 1. On the bottom I have 1/2 times 1, which is 1/2. And then this is 1 divided by 1/2, which we flip and multiply to solve. And so my answer is 2. Okay. So key concepts for being able to do this: know your triangles, know that, be able to convert from radians to degrees or vice versa. And then I guess the keys here, I had to know that cotan was 1 over tan. That's one of the things I will be giving you. Cosecant is 1 over sine, again, given to you. And then just sort of, change everything to sine, cosine, and tan, because those are the ones that we can work with nicely over here, and then plug in the numbers and finish it up. Okay, so that's the first question. I'll do a different video for each one so that if I get interrupted, it won't be a problem.